In section R4, we are performing operations with fractions. So, first we want to simplify rational expressions. So here's some things you need to know. Basically, if you want to simplify fractions, then if both the top and the bottom, the numerator and the denominator, are divisible by the same number, then we can simplify. So like for this example here, we have 10x is 2 times 5 times x, and 15x is 3 times 5 times x. The 5's and the x's cancel out, and so reduced, we have 2/3. So you can see for our property here, these c's cancel out and just left us with a over b. So the first example we want to simplify is not as obvious what we can cancel out here. So guess what? We need to factor first. So what we'll do is factor the top. This is a difference of squares. So that means we have x plus 4 times x minus 4. And on the bottom, if it's a trinomial with a leading coefficient of 1, so we just ask ourselves what multiplies to give us negative 12. That adds to give us negative 1, and that would be negative 4 and positive 3. So, let's see, what cancels out? The x minus 4's cancel out. So reduced, we have x plus 4 over x plus 3. And that's as simple as it can go. Example 2, what we have here is the same thing as 8 over 4 plus 2 square root of 7 over 4. And so, of course, things will reduce here. 8 over 4, that just gives us a 2. And here, we can cancel out 2's, and it leaves us with a 2 on the bottom. So reduced, we have 2 plus the square root of 7 over 2. Adding and subtracting and multiplying and dividing fractions. So with multiplication, it's pretty simple. You just multiply straight across. With division, you take the second fraction, flip it, and then multiply straight across. Addition and subtraction, you have to get a common denominator. So we'll look at some examples for that. The first example I've got on here is one that you would have seen back in 3rd or 4th grade. So I wanted to start with something simple so you could see where we were going. So in this case, the common denominator between 12 and 6 would be 12, because both 12 and 6 will go into 12. We'll divide into 12. So I'm going to go ahead and put my 12's on the bottom here. Well, the first one will stay the same. The second fraction, what we'll do is to get the bottom to be 12, we need to multiply by 2. So what we do is we multiply the whole fraction by 2 over 2. The bottom needs to be multiplied by 2. And so if we multiply the top by 2 also, we're essentially multiplying by 1, which is allowed. So we get 22 over 12. And that gives us 29 over 12. The Common denominator stays the same for the answer. Next one, let's see, we have 4a and 10a squared. Well, we need something, first of all, that both 4 and 10 will divide into evenly. You could just multiply 4 times 10 and get 40 if you want. There's nothing wrong with that. I prefer to try to find a smaller number. It just makes things easier in the long run. But it's totally up to you. So let's go with 20 because both 4 and 10 will divide into 20 evenly. And then we need to deal with the a and a squared. We're going to use a squared because a squared will go into a squared 1 time and a will go into a squared 2 times. So we need to see what are we going to multiply 7 over 4a by and 11 over 10a squared by to get a 20a squared on the bottom. So let's see. 4 times 5 gives us 20, and a times a gives us a squared. So we're going to multiply our first fraction by 5a over 5a. That gives us 35a on the top. The second fraction, 10 goes into 20 2 times, and a squared into a squared is just once, so we just need to multiply by 2 over 2. So we have 22 on the top. And then we reduce. So we've got 35a and 22. We cannot add those because they're not like terms, so we'll just write it down, adding. And on the bottom we have our 20a squared. Now if you can reduce that, that would be nice. Written like this, it cannot be reduced. We could separate things a bit and reduce, so let's do that just in case you need to have your answers like that. So what if we say 35a over 20a squared plus 22 over 20a squared? Well, that's just going backwards. So, yeah, I don't think we need to do that. That's just going to take us back to what we had. So, I think we're good with stopping here. We've got our least common denominator and our, it's as simple as it can go. Next. Now, we've got these two different trinomials on the bottom. So when we're working with these, what we want to do is we want to factor the bottoms first. So for the first one, what will multiply to give us 3? That will add to give us 4. Well, 3 and 1. For the second one, what will multiply to give us -3? That'll add to give us -2. Well, that will be a -3 and a +1. And we still have the same things on the top. Okay, so what have we got on the bottom? We've got an x plus 1, an x plus 3, and an x minus 3. So we've already got an x plus 1 on the bottom of both fractions, so we don't need to deal with that. We just need to take into consideration that x plus 3 and the x minus 3. Let's see, I think I've done something wrong here. Yep. That should be a +3 there, shouldn't it? Okay, sorry about that. So we've got x plus 3 is the same on both bottoms. Okay, so on the first fraction, we need to get an x minus 1 on the bottom. So we're just going to multiply the top and the bottom by x minus 1. When we do that, we're going to have to FOIL here in a minute. We can't just write it out. We have to put them in parentheses. So we multiply everything together. So then we have x plus 1 times x plus 3 times x minus 1 on the bottom of our first fraction. And then for the second one, we need to get an x plus 1 on the bottom. So we'll multiply the top and bottom by x plus 1. So same thing on the bottom. And on the top, we have our x minus 5 multiplied by x plus 1. And now we just start simplifying. So our bottoms are the same. So I'm just going to make a really big one down here with the x plus 1, x plus 3, x minus 1. And so we need to FOIL the top of the left-hand fraction. So first would be 3x squared. Outer is negative 3x. Inner is 5x. And last is negative 5. Looks like I'm going to have to make this a little bit bigger. Okay. And then we're adding, so we don't need to worry about a parenthesis here. If we were subtracting, we would, because we would have to distribute the negative through. But since we're adding, we're good there. So we have x squared plus x minus 5x minus 5. Then on the top, let's combine like terms. So we've got 4x squared minus 2x minus 10. Now, an important thing here is we need to make sure that this 4x squared minus 2x minus 10 doesn't factor. So I'm just going to go off to the side. You don't have to write this down yet. Let's make sure that it doesn't factor. We'd have to see what would multiply to give us negative 10 that would add to give us negative 1. Yeah, and I don't think there is anything, is there? So we don't have to worry about simplifying this any further. If we did, then we might be able to cancel out some binomials, but not in this case. And our last example is fractions in a fraction. Okay, so let's first deal with the top. So we've got x over 4 minus 4 over x. What would our common denominator be? Well, it would be 4x, just 4 times x. So we need an x on the first fraction, so we'll multiply by x times x. We need a 4 for the first one, or for the second one, so we're going to multiply that 4 times 4. And so we'll have x squared over 4x minus 16 over 4x. When we subtract that, that gives us x squared minus 16 over 4x. And I believe we can tell there's already something we can do with that. There is a perfect square on top. So we have x plus 4 times x minus 4 on the top and over 4x. So now the top is completely simplified. And so now we'll look at the bottom. We have 1 over 4 plus 1 over x. Again, I do believe that our common denominator will be 4x. So we'll multiply by x over x for the first fraction and by 4 over 4 for the second. So we have x over 4x plus 4 over 4x, which gives us x plus 4 over 4x. So what we've got then is we have our top now over our bottom. Okay? To further simplify that, since we're dividing, then we're going to flip and multiply. So, oh, wrong thing, sorry. We have our top times our bottom flipped. So we have 4x over x plus 4 now. So what we end up with on the top is 4x times x plus 4 times x minus 4, and I just put the 4x out front because apparently that looks better. And then we have 4x times x plus 4 here. And you can probably already see that we can cancel out an x plus 4. That leaves us with 4x. Oh, nope. There's more we can cancel out, isn't there? We can also cancel out those 4x's. Okay, so it looks like all we're left with is x minus 4. And that concludes section R4.